Okay. So, question, first one, am I doing it? Yes, no, maybe? Yeah. Right, thank you. Right, okay. Okay, so here's the surface area of the three sides. So, right, if we go, I might go on the board. Would that be okay if I just move it aside and go on the board? Right, because I think you'll see it better. Okay, so this one surface area, x multiplied by y, when you multiply x by y, you get 4 root 3. Okay, when you multiply x by z, you get 2 root 2. And when you multiply y by z, you get 8 root 6. Okay, now there's a couple of ways to do this. Okay, right, I want to get the volume. So the volume is x multiplied by y multiplied by z, yeah? That's what they want me to get, the volume. Okay, so what I could do is is that what they want me to get? Find the volume, yeah. Okay, so one way to do it, right, okay, is you could multiply all three of these. So multiply them, so sorry, I put a dot for multiply. So xy multiplied by yz multiplied by xz. Okay, so that would be equal to 4 root 3 multiplied by 2 root 2 multiplied by 8 root 6. Is that okay? That's one way of doing it. And when you multiply those, you get x squared, y squared, z squared. Right, and multiply over here, you get 64 times the square root of 3 2s are 6, 6 6 is 36. So that's 664s, which is 384. So you get x squared, y squared, z squared, 384, I think. And then to get what x, y, z is, you just get the square root. So it's the square root of 384. And I think when you do that, you will get, anyone help me? 8 root 6. Thank you. 8 root 6. Okay, that's one way to do it. Did anyone do it that way? That's probably the shortest way to do it, okay? But there is another way to do it where you actually solve, okay? So if I just write everything in terms of x. So I'm going to show you the other way as well in case some of you started the other way and didn't get to finish it. So you know the way xy is equal to 4 root 3. Sorry, you can't see because it's magnified. Apologies. Right, xy is equal to 4 root 3. Right, I can say y is equal to 4 root 3 over x. Yeah? Okay. And then I can say xy, so I'll go with xz is equal to 2 root 2. So I can say z is equal to 2 root 2 over x. Yeah? Okay, and finally the last one then, yz is equal to 8 root 6. So I have y in terms of x, which is 4 root 3 over x, multiplied by z, which is 2 root 2 over x, and that equals to 8 root 6. Can I move it up? Would that be okay? Right, multiplying out there, that's 8 root 6, is it? 8 root 6 over x squared equals 8 root 6. Does x turn out to be 1? Did anyone do it this way? Right, okay, cross multiply, you get 8 root 6 x squared equals 8 root 6. And then divide by 8 root 6, so you get x squared is 8 root 6 over 8 root 6. So that means x turns out to be 1. Is that okay? Then you can figure out what y is. So y is equal to 4 root 3 over 1, right? So that's 4 root 3. And z is equal to 2 root 2 over 1. So that would be 2 root 2. Okay, so then the volume is equal to x times y times z, which is x is 1, which I'm not convinced about, y is 4 root 3, and z is 2 root 2. So multiplying that, and you get 8 root 6. Is that what I got a minute ago? Yeah? Oh yeah, it's right. So yeah, volume is equal to that. Is that alright? Okay, so that's just a second way of doing it. Okay, that's probably more of a way we'd be used to, right, as opposed to the other way. The other way was just spotting it. Okay, and this is the method, right? So write y in terms of x, write z in terms of x, and then change the third equation into just an equation with x in it, and then you can solve. And then once you've x, go back and get y, and go back and get z, and then get your volume. Is that right? Okay? Moving on. Are we okay? Right. Am I doing the next one, the cone? It says, show that the vertical height of the cone is 8.37. Were you able to do that? Do you want me to do that bit? Do it? Right, okay. So what we have is a cone. Now, and we have the radius of the cone, which is 3.3 centimeters. You have the slant height of the cone, which is 9 centimeters. And they want you to get the vertical height. So the vertical height is here. Right, so what you have there is right angle triangle. Right, this is 3.3, this is 9, and you're missing the vertical height, so I'll just call that x. So 9 squared, Pythagoras' theorem, equals x squared plus 3.3 squared. And when you work all that out, you should get x is equal to 8.37 centimeters. Is that okay? So it's just Pythagoras' theorem. Good? Are we all okay? Right, part 2, that was part 1. Part 2, find the curved surface area. Right, correct to 2 decimal places. So the curved surface area of a cone, it's in the log tables, it's pi RL. So that's pi multiplied by 3.3 multiplied by the slant height, which is 9, into the calculator, press S to D, because you don't want it in terms of pi and round it up to 2 places decimals. Are we good with that? Okay, it's pretty straightforward for higher level. We've just done a Pythagoras' theorem and filled in a formula that we got in the log tables, yeah? Are we good? Right, part 3. The diagram shows the net of a cup. Find in degrees the size of the angle theta. We did one like this yesterday. Will you remind me to change the roll before you leave, please? So this is 9 centimeters. Okay, so that's part of a circle, right? Okay. The diagram shows that find in degrees the size of the angle theta. I need more information, do I? Degrees the size of the angle theta. Oh no, I have that. Right, that's that cone up there, isn't it? So what does this measure? When I flatten that out, what would that measure? It would measure it's the circumference of that circle, isn't it? You know, when you flatten out your cone, you get this and a circle on top. And that circle, the circumference of that circle is equal to the length of that, the curvy bit there. Okay? Is that alright? Because when you fold it around, that makes the circle.
Excuse me, please.
Yes?
Could the minor A hockey team please go to the hockey pitch at 10 a.m. this morning? Please bring hockey gear with you ready to play. Would Maya Rooney come to reception at the bell, please? Thank you.
So that curvy bit there is the circumference of the circle, right? So the circumference of the circle is 2 pi r, 2 pi by 3.3. Agreed? Are we okay? Right. Okay, so we know the formula to get the circumference of that circle is theta over 360 multiplied by 2 multiplied by pi multiplied, the radius here is 9, right? And you know that would be equal to the circumference of this circle up here. So that's equal to 2 multiplied by pi multiplied by 3.3. Is that okay? So there's a pi at each side, you can knock it off. There's a 2 at each side, you can knock it off. Here we'll end up with 9 theta over 360 equals 3.3. Cross multiply 9 theta equals 3.3 by 360, and then divide by 9. So multiply that, divide your answer by 9. Anyone have an answer for me? 132 degrees. Okay, is that right? Okay, and actually one of the test or the core revision exercises was that yesterday, except they kind of spelt out that this bit was 2 pi r. Okay?
Yes, I do put the 9 over the 360.
Because multiply 9's on top, 9 by theta is 9 theta, and there's a 360 on the bottom. I just multiplied.
So do you put the radius like with
Yeah, because I got it's 2 pi r, right?
all
If I was to get the circumference of that circle, it would be 2 pi r. So the radius, they told me the radius is 9 of this circle. Okay, whereas that radius up there was the radius of this circle up here, which was 3.3. Is that okay? Questions? Are we okay? Right, next one. Right, I think you probably have to use, maybe you don't, similar triangles here, I'd say. Right, can I move on? Is that okay? Right, so I'm on to B. Right, okay. In order to avoid spillages, each cup is marked with a dotted line F, which is 1 centimetre vertically below the cup as shown. Find the volume of water in the cup when it is filled. Okay, so basically we have a right angle triangle there, which was 3.3, and I know this is 8.37, yeah, because I got it already, and I know this is 9 centimetres because I also had that already. Agreed? Okay, so you want to move it down, okay, right? So when you move it down 1 centimetre, so you want to move it down 1 centimetre, you actually make a new right angle triangle. So the new right angle triangle has 7.3 centimetre, is 7.37 because it went down 1 centimetre, right? You don't know the slant height and you don't know the radius. Okay, is that alright? So we have the original bigger triangle, which is 3.3, 9 and 8.37, and now you've made a new triangle which is 7.37. We don't know the radius and we don't know the slant height of that. We don't know L either. Is that okay? Right. We're looking for, when we make the new cone, when we reduce it by a centimetre, we make a new cone there. Right, okay, and find the volume. So we want the volume of the lower down cone. So remember, the volume of a cone is 1/3 pi r squared h. So I need the radius of this cone and I need the height. I have the height, it's 7.37. Okay, is that right? So that's my end goal, to find the volume of the cone that gets lowered when it gets lower down a centimetre. But I need the radius of that cone, so that's why I'm using these, looking at these triangles. These triangles are similar, so similar means the three angles are the same, as in that's a right angle, that's a right angle. This is the same angle, okay, so if two angles are the same, the third one must be the same, so they're similar. Okay, you don't need to write that out, you can just assume they're similar, okay, right? So the whole point of similar triangles is their sides are in proportion, okay, that's why we have similar triangles because their sides are in proportion. So you take the side in the big triangle, 8.37, you put it over the corresponding, the matching side in the smaller triangle. What does that measure? 7.37. And that would be equal to, the radius in the big triangle is 3.3. All over the radius in the small triangle is what I'm looking for. Okay? And then you cross multiply and you divide, right? And you round, no, you don't round it up because we're only getting the radius. So you work out what the radius is. Will someone work that out for me? Or if someone has an answer, that'd be great. Don't round it up for a few minutes. So 2.905. Okay, that'll do me. Okay, so that's the radius. But the question was find the volume. So the volume is 1/3 multiplied by pi multiplied by 2.905 2b squared multiplied by the height, which is now 7.37. Okay, and you'll find out how much water is in the cone. Is that right? Okay, I think I might need that for the next bit. Water flows into one of these cones through a cylinder. Yeah, I need the answer to that. Someone might give me the answer to that. Yeah, 65.3 to one decimal place. So do me 3. Is that what you said?
No, I think you were another round.
No, I'll go with 2. cm cubed. Okay, is that right? Are we good? So then we have to go to the next bit. So the next bit is we are filling that cone, okay? So the cone that we just right, we are filling it with a water flows in it through a cylindrical pipe. So it's a cylinder, right? Okay, so there's a cylinder, right? Okay, of radius 0.8. So I have the radius of the cylinder, now 0.8. Okay, and it goes in 2.5 centimeters per second. So if you just do one cylinder every second, that much water goes in. If you get the volume of that, every second that much water will dump into the cone, yeah? So if you get the volume of this cylinder, that's how much water goes in every second. So the volume of a cylinder is pi r squared h. So that's pi multiplied by 0.8 squared multiplied by 2.5 into the calculator with that. Someone might throw me out an answer.
I think it's
5.0265.
Yeah.
Yeah, so that means every second that much goes in. So that much water goes in every second, because they said the speed that it filled was that many per second. Okay, is that right? So that's the volume that goes in every second. You know the volume of the cone you're trying to fill, it's 65.2. Yeah, okay. So you divide that by 5.065 and you round it up. No, you don't round it up, they don't tell me. Find to the nearest second, so you round it up to the nearest whole number. It's probably 13, is it? 13 seconds. So it'll take 13 seconds to fill that cup. Is that right? Okay. Yeah. Don't worry about the name in it, because I gave it out to Todgers and by accident, and they all wrote their names on it. But it's okay. It's more than 3 days ago. So, right. Are we okay? Right. And D then. the company decides to change the position of the line F in order to limit the capacity of the cup to 60 centimeters cubed. So basically the small cup, right, okay, we now want that to be 60 cm cubed. Okay, so we want that. We don't know the radius, right, okay, and we don't know the height. Okay, is that right? So we don't know the radius, we don't know the height, right? The company decides to change the position of the line F in order to limit the capacity of the cup to that. How far vertically below the rim of the cup should the line F be drawn? Okay, so originally, my original cone was 3.3, 8.37, right, and 9, isn't that right? That's all my original dimensions, right? We're dropping it down, okay, to make this triangle over here. So that's R, that's H. Don't worry about L because we don't need it. Is that right? Okay. So should the line F be drawn? So we have 1/3 pi R squared H. We want that to equal to 60. Right, so let's do our similar triangles. Okay, now I have two unknowns, but I'll be able to play around with it. Okay, is that right? So I go 8.37 all over the matching side, which is H, yes? Right, over this side, then I pick the radius, which is 3.3 all over R. Cross multiply 8.37 times R equals 3.3 H. I'm just going to express R in terms of H. So R is equal to 3.3 H over 8.37. Okay, is that right? Then over to this equation, everywhere I see an R, I'm going to put in that 1/3 multiplied by pi multiplied by 3.3 H all over 8.37, all to be squared, multiplied by H is equal to 60, and you can solve that. Okay, can't you? Because it's just one H. So what you do is you multiply 1/3 multiplied by pi, so you go 1/3 multiplied by pi multiplied by 3.3 squared, and you divide by 8.37 squared. 8.37 squared equals, I'm thinking I'm getting 0.1627 H cubed. When you work all that out, equals 60. Now this is going to be crazy big because I've done something wrong. I think I've multiplied wrong. 60 divided by the answer equals, yeah, I've definitely done something wrong because I've got that the height is 300 something. Everything is right, I've just multiplied wrong, so I probably typed it in wrong. So 3.3 over, if anyone wants to jump in and do the calculating, 3.3 squared multiplied by shift and pi multiplied by 1/3 equals, yeah, no, do you know what, I'm right, I just forgot I had to get the cube root of the answer. So 60 divided by answer equals, so you get H cubed is equal to 368.59, and then you get the cubed root of your answer. Sure, I had it right, I just forgot to get the cubed root of the answer. No. Shift that answer equals 7.1. So the height is equal to 7.169, and the question was find the how far vertically below the rim, right? So the rim was at 8.37, you needed to be at 7.17, right? Subtract that, and that would be 1.2. So 1.2 centimeters below the rim. Is that right? Okay. Are we good? It's a bit of work in that. Right, okay. Right, observations, girls. Right, the first few bits, right, were Pythagoras' theorem, get the volume of a cone. Right, the first few bits were very doable. Agreed? Right, the last few bits, you may or may not, right, have been able to do them, but you need to do a step in the right direction. So everyone can write down the right formula, can't they? And you can fill in one correct thing into the formula, and you get marks. Okay, right? So you know, similar triangles, I hope it's revised now from junior cert. I hope it's a bit better, but you know, like, there's no reason why we can't get attempt marks or even beyond attempt marks in all those hard bits. Okay, so there's perfectly easy bits, right, and attempt marks or beyond in the hard bits, girls, and you're on like a H3, a H2, H3, and then everything after that is the bonus. Agreed? Okay, so I thought that question was very doable. I know the last few bits were really hard, and the similar triangles are junior cert, and you probably haven't seen them since, but I actually thought that was a very doable exam question. Okay, there is 2 questions left on the paper there. Right, I'm not going to get to be able to correct those before tomorrow because you haven't been done yet. Okay, so I'll put up the answers on Teams to this. So have a go with them, right? Okay. If you feel it's of value to your revision, remember you're doing the test tomorrow in the first class. So your homework is revised for the test. So if you think doing these questions might help you, right, do them, right, and I'll put up the answers so you have them. Is that right? Okay, right. But that first question, right, okay, is very, that Coney question is, I thought that was quite a, I won't say easy question, but quite a doable question. Okay, right. Okay, so your test is tomorrow, so that's all I'm saying. Let me stop this.